looking at a transformation of a semicircle function. We've already, I think, graphed this beforehand, so I'm not going to spend too much time on that. But let's take a look here. So here's just an axis. The original has a radius, again, make sure you write this in a way that you can read off the radius. So 9 is 3 squared, so that means a radius of 3. And again, the original circle goes something like this. Now, these numbers here are going to be our shifters. Back 2 and down 5. So this original graph, which I'll just paste on top, will go back 2 units. So 1, 2, and then down 5. 1, 2, 3, 4, 5. And we end up with our new shifted function over here. Put in this broken line and across. There we go. And our middle, the center of our circle, is -3, comma, what do we have here? And -5. Oh, no, not -3, and -2, my bad. So -2 and -5. Okay, so we've taken care of the horizontal transformation, the vertical transformation. All that's left now is this business up here. And if you recall, the negative will reflect us. Will reflect us in the x-axis, and the 2 is going to stretch us vertically. So first off, I get a reflection. And I'm going to do this in a different color just to distinguish it from the original. So I'm going to get this coming down here, making a full circle. Okay, so this is going to be the reflection. And then I'm going to stretch it. I'll use a different color for that by a factor of 2. So everything here is going to stay the same, except that it's going to be a bit pulled up, down, and it'll look kind of like an oval. So factor of 2 stretch. Okay. And that'll be the red. Okay, I'll erase this, I'll erase this. The red will be our final graph. Okay, and it's everything from here to here. If you wanted to see this in terms of like a mapping notation with a table of values, what you could have done is, again, draw kind of the base table for the semicircle, where you have your x and your y, -3, 0, 0, 3, 3, and 0. Again, all I'm doing is just labeling these points, this one, and this one. Okay, this one is -3, 0. This one here is 0, 3. This one is 3, 0. And applying this transformation to it. xy maps to x minus 2, comma, -2, y minus 5. And just plug in, one pair at a time. This guy, then this guy, then this guy for x and y. Get your points that are transformed, and you get your final graph. So what's the domain here? Domain doesn't change. Okay, it'll be all real numbers, such that x will be, let's see here, for -3, go from -5 all the way up to 1. And that makes sense because there's radius of, diameter of 6, radius of 3, and the range will be all y values such that, well, the topmost part here is going to be -5, and the bottommost part here, well, we can find that by plugging in this 3. Where's that going to take us? 3 into this part will be -6, -11. So -11 less than or equal to y, less than or equal to -5. And there's our range. So our final graph is this one here in red, domain and range as identified.